Hello, everyone. Welcome to Feedstuffs 365. I'm Sarah Muirhead. John Shutsky, engineering professor and extension specialist with the Department of Biological Systems Engineering at the University of Wisconsin in Madison, joins us today, and we're going to talk about autonomy in agriculture. In particular, we're going to talk about safety and risk associated with this technology and what needs to be done to take into consideration as this technology is adopted. John, thanks so much for joining us here
Oh, yeah,
today.
Sarah, thank you so much for having me. I appreciate the invitation to come on and happy to be here.
Yeah, I think it's going to be a great discussion. So, there's a lot going on in agriculture when it comes to the advancements in technology. We've got what improvements in production, efficiency, sustainability. All those are very positive things that we're looking towards as we move into a lot of this autonomy. But there's also probably some things we should look at when it comes to risk and safety. So tell us, what is at stake and how best does one go about developing an understanding of that associated risk, whether it's perhaps financial, injury, insurability? There's a lot of things to consider. If you could like kind of frame up that
Yeah,
discussion for us, that would be great.
yeah, no, it's a great question. And so a lot of my work is around safety and safety engineering. And one of the things that we know, first of all, let me just begin by saying agriculture, production agriculture it's the country's most dangerous occupation. Literally by sevenfold. We have about 500 farmers or ranchers who die every year in the farm workplace, another roughly 100 children, and a couple 100,000 serious injuries. And one of the things about automation that's actually promising in the future is if we can employ more machines that don't require the direct involvement of a human operator or a bystander, we have the possibility of improving safety. And as we look at all of these machines out there that are now in, there may be a YouTube video or a concept vehicle or a concept like a tractor or some other type of platform, but also the things that are being used, like milking robots. Here in Wisconsin, we're dealing with a lot of labor issues, labor cost, labor availability. As we look at that, there's a lot of interest, but we also need to make sure that we're thinking about, yes, we can improve safety by employing automation, but we also have to think about the sort of unexpected safety consequences of a piece of automated equipment, regardless of its size or scale. And one of the things that I'll just note to you, Sarah, is we know in farm injuries and farm fatalities, a lot of these catastrophic incidents happen when there is a failure, a breakdown, a repair that's taking place. In some cases, it might be being done by a person who's not quite experienced enough to actually perform that repair safely. So I think that automation shows great promise, but we also need to take a kind of a step back. I'm not at all concerned about the big manufacturers, the CNHs of the world, Raven, John Deere. I shouldn't probably list the whole array of people that I would consider to be big manufacturers. But what I am a little bit concerned about is out in California and other states where we have startup technology companies. Some of those companies may not be thinking safety first. And so I think it is important that we make sure that the technology doesn't get too far ahead of us as we think about this dangerous occupation. And also the fact that, and you mentioned this, insurance companies finance a lot of the risk. And I think that they're struggling to sort of keep up with what's happening in this new world that shows promise. But I think we also need to be careful with how quickly we proceed in terms of the risk that's involved.
So you frame that up, but when we look at new technology, kind of what comes first or what is kind of an acceptable lead time, right? You have to have the technology and what that technology is capable of doing, but then at the same time or after that's kind of all that is known, is that when you start really looking at the risk and the safety, or how does that come together?
Yeah, so this is hard, and I have a friend who I work with from one of these big companies, and he kind of likens it to the space race back in the early, well, I could say late 1950s up until the time we first landed a person on the moon. A lot of this was so new, we just sort of learned by trial and error, and it's a little bit scary. One of the things that I teach in my classes, I teach, in addition to doing extension and research work, I also teach in our senior design capstone program. And we always teach risk assessment, making sure that people are thinking about all of the hazards on a piece of equipment or some type of a new machine or a new system or technology. And when we do risk assessment, in many cases, we have to look backward historically. When you do risk assessment, you do two things, actually, do three things. You try to predict what is the probability that something could fail and something bad could happen. And if that bad thing happens, is it really bad? Is it just like a kind of a minor nuisance? Is it a scratch? Is it an hour of downtime? Or is it the possibility of a fatal rollover? Or if it's a case of a power takeoff driven implement, maybe an entanglement. Both of those processes in risk assessment, probability and severity, both of those require data. And with brand new technology that we've never really fully deployed or employed, that's a little bit scary because we don't have the data upon which to really do good quality risk assessment. One of the things that I'll notice or that I'll note to you is here in the US, but also internationally, including through the International Standards Organization, companies have standards that help them to do risk assessment. But again, a lot of those methods in the standards are predicated on having data. So we have a little bit, as you suggest, we have a little bit of a chicken and egg situation. We hope to rectify that here in the next maybe 4 or 5, maybe 10 years as we begin to like slowly roll these equipment out or these types of equipment out and then begin to develop the experience and the track record and using, again, repairing, maintaining, and taking that machine through its entire life cycle.
So where, in your opinion, are we at right now in terms of collecting that data and being able to take uh, a fair look at that risk and safety?
Yeah, and I think it depends very much company by company. There are some companies that have actually been experimenting with pretty much full autonomous equipment out in places like California, with in many cases hundreds or thousands of hours of operation. I know that there are a couple of companies out there who have met with regulators in California, and they say like, we've had more than 1,000 hours or 2,000 hours of operation without a single incident or even a close call. I know that for a fact that some of our big prototype machines by the bigger companies also, lots of like small scale field experiments here in the Midwest. But we really haven't had the opportunities out of sort of a controlled setting on a broad scale to really develop the types of track records and again to begin to collect that data. That will be the focus of a conference we'll be doing here at Champaign-Urbana. I think we'll probably talk about that in a few minutes, but is like how strategically, how do we begin to collect and aggregate that data across the industry so that engineers then have the tools and the data that they need to do these jobs of risk assessment in a careful way. The other group of people who are super interested in having that kind of data, if you run an insurance company, it's all about data. You need to be able to predict for the revenue I bring in from insurance premiums, how does that compare to the losses that I'm paying out? So I know that insurance companies are also really interested in this idea of data and again, the track record and history that we'll have after we have a few years of experience. Again, I don't want to lose sight because I'm sort of suggesting there's all this risk and we need all the data from the risk. I actually, in the bigger picture of things, again, from a safety perspective, I do think we have really great opportunities here to improve the safety of agriculture through automation. So I want to make sure to not lose sight of that point.
So yeah, definitely we'll get into talk about the conference here in a minute, the workshop that you're putting together, because I think that's something folks will want to know about. But let's first talk about what's the role then of regulation and standards, and are there some existing gaps, areas that need attention? Do we even know at this point how things, how things need to be?
Yeah, and I wanted, if I could just clarify for a couple seconds here, a couple minutes perhaps, when we talk about standards. So when I look at things, when I look at standards, I think of standards from an engineering perspective. Engineers use standards that are they're passed by, or I think the word is promulgated by standards making organizations. Those standards that are done by standards making organizations like ASABE, the American Society of Agricultural and Biological Engineers, or another big group, as I mentioned earlier, is the International Standards Organization. They are very, they are embedded with data and research and history. And it's those standards that engineers use in the design of products or systems or components. I feel really good about where we're at with engineering standards. We also talk about standards like OSHA standards. So in agriculture, we have a small set of OSHA standards that are connected to agriculture. One example is if I have workers on a farm and that farm is of a certain size with a certain number of hired workers, those workers who are driving tractors have to be equipped with a rollover protection system and a seatbelt, or ROPS and a seatbelt. So that would be an example of a regulatory standard. I personally think what is most effective are regulatory standards that embed engineering standards. And the reason for that is you've got the science, you've got the research, you've got the data that forms the foundation for that regulatory standard because of just basically time and also the consensus that's represented through industry design standards. So that's kind of like I'm parsing the words just a little bit here, but there are different types of standards. One of the things that I'll say on a regulatory front is there are some states here in the Midwest who regulators and policymakers, autonomy is probably not on most people's radar screen. And it does worry me a little bit because I'm concerned that if we begin to, for example, in a state like Wisconsin, we begin to see autonomous tractors, autonomous maybe harvesters or applicators, whether that's manure, fertilizer, crop protection chemicals. And if an incident does happen, suddenly there's going to be a call for regulation. And I want to make sure that those regulations are well thought out. And again, that they have a foundation of engineering standards. I will also say, and I think I'd be remiss not to do this, in the state of California, I believe is our biggest agricultural state in the country, there have been some attempts to modernize and update some of the regulations that right now are serving to kind of hold back automation in particular, or I should say autonomy, in particular with some of the bigger field equipment like tractors and sprayers and other types of bigger platforms of equipment. So we need to make sure that regulations, they will happen. I can almost guarantee that, but they're smartly thought through and that they have this sort of foundation of science and engineering and the history and the data that goes along with those.
Do you think that regulation will result from what's also being done, say, on the automotive side? Is it something that's where it's really starting and then it's flowing over into agriculture, or is agriculture really where some of these regulators and policy things might be specifically focused?
Yeah, so it's really hard to say. Like, if I think about here in Wisconsin, again, I don't think that autonomy is really on the regulators, the people who are doing regulatory work. I don't think it's necessarily on people's radar screens. If I think about what I know about California, I'm actually going to be out there in Fresno, California at a autonomy conference, autonomy on robotics conference next week. I don't know that they're necessarily connecting what's happening on public highways with motor vehicles with farm equipment. I think in the case of regulators in California, it's a totally separate entity. It's California's OSHA, the state OSHA agency of the state. Again, I'm not an expert in California regulation, but I know that it has been one that the industry has tried to introduce data. I don't know that they've tried to connect the automotive industry with it. But they're beginning to bring the data to the table, and I think that there's some struggles, and I think it's an area to be watchful of in the future. Obviously, what happens in California to come here to Wisconsin may take 3 or 4 or 5 or 6 years, but it'll eventually move across the country in some form or fashion. So California is a state to watch when it comes to regulation.
So they'll get in that autonomous cab to go to the protest against autonomous agriculture. So is there certain technologies or applications within agriculture that perhaps cause the greatest concern? I mean, you've got self-driving tractors, you've got these big autonomous harvesters, picking apples or produce of some sort. You got spray drones. Is there something from a safety or a risk standpoint that perhaps causes a little more concern than other
Yeah.
technology?
So as an engineer, and all the students in my classes, they can run circles around me when it comes to physics. But when we talk about physics, or when we talk about safety, we have to talk about physics, because a lot of times when we have somebody who is seriously injured, there's a big force involved, and force is kind of a function of both the mass. So if you have a big, huge, massive autonomous vehicle, it can do a lot of damage if it behaves in a way that was unexpected for whatever reason, or if a person gets in its way. The other factor is acceleration, which is a function of velocity. So anything that's big and fast moving, and that fast moving can not only include like the ground speed of a vehicle, it can also include like, the rotational velocity of moving parts and components. So again, I think anything that's big, that's got a lot of rotating components, anything that is moving quickly through a field or other location, is a cause for concern. I think that we're beginning now to better understand some of the human factors. So if you've got a electrically powered autonomous robot, I think you mentioned picking fruit, you need to make sure that it creates enough noise. It might be something that would normally operate very quietly, but it needs to create enough noise that people, don't accidentally walk into it, or like as they're doing their work, backing up into it. So I think it's complex, but from an injury perspective, I think about the impact of force, mass, and acceleration, velocity. The bigger stuff is what worries me. When I was at World Dairy Expo here in Madison, Wisconsin last week, I looked at a couple of robotic applications. One was a large scale cattle feeder. I don't know for sure, but probably fully loaded, weighs a couple tons. And then we also had essentially, it was a barn cleaner. I guess I'd call it like a manure Roomba,
Mhm.
and smaller, lower to the ground, probably moves very slowly. I'd be more concerned about the bigger, heavier, bulkier equipment that's got a lot more complexity and a lot more moving components.
Are we gonna be able to get farmers out of those cabs?
Yeah, so again, when we talk about this stuff, it's not super easy. My dad, who passed away, was a corn and soybean farmer in Indiana, and I never talked with him about fully autonomous tractors. I don't think he would have given up the old 4240. I don't think he would have given up any of his various John Deere combines that he operated. That was just part of the job, and he loved it. And I think for a lot of people, I think it's the same way with driving. I love to
Mhm.
drive, and so the thought of something 20 years from now, when I'm pushing close to my 80s, being driven down the highway is something that I don't have a huge amount of control over. I don't know if I want to give that up. And I think that that's a pretty common feeling. The other
So
thing
let's
that I would say to you, though, on Twitter, I don't know why this year in particular, on Twitter, I've noted a lot of farm families that are featuring their little, in some cases, 12, 13, 14-year-old. I saw one this morning, and he said, my 12-year-old kid yesterday spent 7 hours by himself in the combine. You could argue that's probably not the safest thing in the world. I'm not going to question an individual parent. But if you think about something that's that complex that can be done by a 12-year-old, it does suggest like, hey, for those people who don't have the time or the manpower or the person power to be able to hire a person to do that job, that is a possibility to automate a task like that.
Exactly. Well, let's talk about your upcoming workshop that you're involved in coordinating. It's going to look at technology, safety, risk. Tell us about that. I know it's down in Champaign and in November, so give us some details. I
Yeah.
think we've posted a link there too.
Yeah, thank you for posting that. So, we have a conference coming up. We were invited by USDA, United States Department of Agriculture, and their National Institute for Food and Agriculture to do a conference, to do a workshop. And I will say it truly is designed to be a workshop. The people who attend this are going to work. And what we are trying to do is we've divided our workshop into three domains. And by the way, we would love to have producers there. We have a lot of people from academia. a lot of people doing research, and we have a ton of people from the industry who will be there. We're divided up into three groups. One of the groups is going to look at, like, from a company perspective, risk, the things we've talked about. How do you do risk analysis when we don't have history, we don't have data? What kinds of design standards do we need? How do we get design standards out in front of regulation, just like I talked about? So that's one group. Another group is the research community. Like, what are all of these research questions? How do we frame them? How do we prioritize them? Like, for example, one of the things I'll bring to the table, I know from my research, is that people don't get hurt when they're out and everything is operating correctly. It's when a breakdown, repair, or maintenance occurs. So how do we, like, prioritize that research agenda so that groups like NIOSH, that's the National Institute for Occupational Safety and Health, or the National Safety Foundation, or National Safety NSF, how they can maybe fund programs, those sorts of things. And then the last group that will be there are the people who will be thinking about the future impacts on workforce. What kinds of skills will be needed? How do we deal with issues like technology training? The questions you asked about giving up the opportunity to drive a tractor or a combine on a daily basis. We also need to look at things like public policy. Like, what about areas of our state here in Wisconsin that don't have broadband coverage, or where getting, even a smartphone data plan is cost prohibitive for some of the families. So we'll be looking at it from an education, workforce, and kind of a community vitality and policy perspective. The first day is going to be full of content. We're going to have speakers, panels. The second day is going to be those three working groups really hammering out and prioritizing some of these key questions.
So what's the overall objective of the workshop? Is it to kind of start that discussion, start that thinking, and to come to some conclusions, or just to kind of
Yeah,
get things rolling
well,
so that, we frame things up and we're ready to look at it as things move forward?
it's a great question. Our mandate from USDA, what they really wanted us to do is get everybody to the table in these. Well, we've created the three domains, but to get all of those questions onto the table. In some cases, really good resources, really good publications and research exists. So we want to make sure that when these questions are prioritized, we're also linking the questions to the answers in some cases. But we want to get all of these onto the table. And we would like in our workshop to assign roles. For example, the agency that is responsible for occupational safety and health research in this country is NIOSH. We want to make sure that NIOSH knows, as they put out funding requests, requests for proposals from places like University of Wisconsin, they need to be informed. They need to be shooting in areas that the industry feels is the biggest priority. Same with USDA, same with NSF. Because these agencies put out a lot of money, and for them, autonomy and ag automation, it's on their radar screens, but they don't really know how to prioritize and direct those resources. So there's going to be a lot of answers that I think that will come out of this through people coming together, sharing information, learning from each other, researchers learning from farmers, learning from industry, but also there's going to be a lot of questions in terms of where we go next, and, like, what does that roadmap and timeline look like?
I want to remind our audience to post any questions that you might have as we get ready to wrap up here today. We do have a question, John, from broadcaster Max Armstrong. So Max wants to know what is happening in other parts of the world. Are they really ahead of or behind us when you look at some of this autonomy technology? You're talking maybe Europe, Australia, etc.
Yeah, well, first of all, I want to say hello to Max. I do know Max. And the last time I saw Max was actually pre-pandemic at the Farm Bureau conference in Austin, Texas, I believe.
There you go.
Anyway, so yeah, thanks, Max, for the question. So I don't think any of these countries are necessarily ahead of us. I think that Europe, probably in terms of the technology, is probably ahead of us with some of the smaller scale robots. Europe, the European countries tend to have a much different philosophy in terms of regulatory intervention. And I know that there's some concern that we get in this country, here in the US, that we kind of get out in front of that. I know that there are concerns about Europe being very prescriptive in treating all types of ag autonomy very similarly. A small scale, a 200-pound field robot versus a 5-ton autonomous tractor in the field. So I can say that so that we're in different areas, different sort of zones in terms of our progression. I will say Australia has given a lot of thought to some of the regulatory types of things, and also they have something that I think is called a code, or it's a set of standards that are not necessarily promulgated by the government, but they are consensus. And we've got a document out of Australia that we'll probably be using as kind of a model for what our final product for our conference might look like.
Very good. Well, John, thank you so much for joining us here today. John Stutzky, engineering professor and extension specialist with the University of Wisconsin in Madison. We appreciate your time and we wish you the best of luck in your upcoming workshop. Again, that link is posted there if you're interested in learning more about that. Until next time, for Feedstuffs 365, I'm Sarah Muirhead.